All right, number 17. 1/4 y plus 2/3 and 2/5 y plus 1. All right, this one's going to be a challenge. Pause it if you'd like. 1/4 times 2/5 y times y. All right, so I definitely have y squared here because of the y times the y. And then I have 1/4 times 2/5. So don't forget about our side problem over here. Top times top and bottom times bottom. And that can actually be reduced to 1/10. So I have 1/10 y squared. Now I do the outsides. Ooh, I love that it's plus 1 over here because that means I'm just going to have 1/4 y still, because when I multiply by 1, nothing changes. It's even positive 1. So again, awesome. Nothing changes there. Now I do my insides, and I have a certain number of y's. I have 2/3 times 2/5. So I've got a second side problem over here. Top times top is 4, bottom times bottom is 15. So 4/15 y. And finally the lasts, and again that plus 1 is my friend down there because it means I'm multiplying by positive 1, so nothing changed there. All right, the ickiest part of this problem is probably coming up, where we have to combine like terms. Or maybe perhaps you find it the most exciting part. I don't know. So we have 1/4 y and 4/15 y. So now we have to come over here and do a third side problem. So we put an S up here, side problems. And I need to combine 1/4 of those y's plus 4/15 more of those y's. So how the heck many y's do I actually have here? Thankfully they're going to be positive because everything's positive, so we're adding and adding. So now we just got to fill in that number of y's that we actually have. To add fractions, you have to have a common denominator. So I have to scale up the 4 by multiplying by something, and I have to scale up the 15 by multiplying by something. And the something that I have to find is what 4 and 15 have together. So I'm going to start with 15 and just count by 15s. So does 4 go into 15? It doesn't. So I'm going to go to the next 15. 15 times 2 is 30. Does 4 go into 30 evenly? It does not. Go to 15 times 3, which is 45. 4 doesn't go into that. So 15 times 4 is 60. 4 does go into 60, 15 times actually. So to get to this bottom number of 60, I have to multiply 15 by 4. I have to do the same thing to the top. So 4 times 4 is 16. So now I've scaled that fraction up. I've rewritten it. It's equivalent, it's called. Because it's equal, it just looks different. It's representing the same amount. To get to 60, for the 1/4 fraction, I have to take 4 times 15 to get to 60. So I have to do the same to the top. 1 times 15 is 15. Now I can finally add the tops only, and the bottom stays the same. So I actually have 31/60ths when I combine like terms. As I said, it was maybe the most exciting or perhaps the most frustrating part of that problem. So for 17, that's what you should have. Oops. I'll paste our textbook in here again, just so I don't have to scroll back and forth. All right, number 19 is 3f plus 2 times the quantity 6f plus 4. Pause now if you want to try this one on your own, because here comes the answer. 3 times 6 is 18, f times f squared. The outside will give me positive 12f. The inside will give me positive 12f. And the lasts will give me positive 8. Combine my like terms, CLT. So we have 18f squared plus 24f plus 8. There we go. All right, 21. We have 20x plus the square root of 21, and then 20x minus the square root of 21. All right, 20x times 20x is 400x squared. The outside is going to give me, yikes, a mess. Negative 20 times the square root of 21 times x. So I'm going to write it like that. And the inside is going to give me positive 20 times the square root of 21 times x. Look at that. And the last is going to give me negative, because it's a positive times a negative, square root of 21 times the square root of 21, which would be the square root of 21 squared. We know those to be opposite operations, so it's really just 21. All right, the negative of this and the positive of this, look at, they're identical. And one is negative and one is positive, so they cancel off. So I just have 400x squared minus 21, and that is our answer. So sometimes these middle terms are going to cancel off. That is a little bit of foreshadowing about what we're going to see coming up here in some of our next units. All right, so that was that answer, 400x squared minus 21. Alrighty, number 23 is b plus 7 times the quantity b squared minus 2. Alright, just because there's a b squared in here now, it doesn't mean we change things up. We still do our firsts, and so we'll end up with b cubed. And then we do the outsides, negative 2b, and the insides, positive 7b squared, and the lasts, negative 14. This is one of those 5%ers because we don't have things that will combine here, but we do need to, because we don't have like terms, because we have a b to the third, a b to the first, and a b to the second term, and then a constant term, right, our plain old number term. So then we just have to write it in standard form since there's nothing to combine. Remember, that's descending orders. Power of 3, power of 2, power of 1, power of 0. All right, number 25. W squared plus 5 times the quantity 2w plus 1. Pause again if you're trying this on your own. Multiply w squared times 2w, so we end up with 2w cubed. The outsides plus 1w squared, the insides plus 10w, and the lasts plus 5. So 2w cubed plus w squared plus 10w plus 5. That is in standard form. Power of 3, power of 2, power of 1, power of 0. All right, as I mentioned in our CC, number 27 is a challenge, and that's because it starts as a FOIL problem for us. X plus 6, that quantity cubed. So I have x plus 6 squared and then cubed. So what I'm going to work with first are just these first two binomials here. Okay, just this first portion. And then we're going to come back and add this part on once we get to, after we FOIL here. So x squared plus 6x for the outside and plus 6x for the inside and plus 36 for the lasts. Simplified, we have x squared plus 12x plus 36. Remember, that's only the first two. We still have times the quantity x plus 6. So now it becomes one of the problems that we could not use FOIL for, but we just have to use distributive property. So I'm going to take the smaller factor here and write it out in front. Okay, then I'm going to take each term and distribute it. So that x will get distributed and multiplied by these 3 terms, and then the positive 6 will also do the same. Okay, so I should end up with 6 terms when I'm all done. All right, so I'll put T1, T2, T3, T4, T5, and T6 for those 6 terms, just to keep it straight. So first I'm going to do x times x squared. And then I'm going to do x times 12x. And then x times positive 36. That distributes the x times everything. Now I'll do the 6 times each of those 3 terms. 6 times x squared. 6 times 12x, and 6 times 36. So now evaluate each term. I've got x cubed, a positive 12x squared, positive 36x, positive 6x squared. That's something going for this problem. It's all positives, plus 72x, plus 36 times 6. Calculator. 216. All right, let's combine collect like terms. So I'm going to use my cloud that I've used in the past to do my x squared terms. I'll use a rectangle for my x terms. I'll underline and circle. There we go. All right, so I've only got one x cubed. For x squareds, I've got positive 12 and 6 more for a total of positive 18 of those x squareds. For plain old x's, I've got 36 of them and 72 more for a total of 72 plus 36 is 108 of those x's, and one plain old number term which comes on the end. So here is the answer to x plus 6 cubed. So again, notice it started as a FOIL problem. We did that part first. It was almost like a side problem. And then we came back and said, oh, we're not done yet though. That trinomial has to be multiplied by this binomial. And then we did those terms, evaluated each of them, and then got our answer. All right, so hopefully you found this helpful and useful. Don't forget you also have your solutions manual if you need it. And of course, because I've uploaded this to YouTube, you can easily scroll through, rewind, pause, fast forward, whatever you need to do. All right, don't forget I also have office hours if you need to come in and see me and work on any of these problems or other questions that you might have. We could also do a couple of the evens together if you would like more practice.